Hi everyone, welcome. Today I'm going to be going over a quick and easy formula to estimate the maximum tightening torque for screws. Specifically, socket head cap screws constructed of carbon or alloy steel with metric coarse threads. And first of all, disclaimer, if safety is involved, don't rely on this method. Look up the values from the appropriate table or contact the manufacturer. Also, for other head types, such as button head cap screws, you're going to need to reduce the torque value. Typically, the torque value for button head cap screws is 60% that for socket head cap screws. Also, if lubricants are involved, you're going to need to reduce the torque values also. I came up with this method myself, and I wouldn't be surprised if other people have come up with similar methods. The formula itself is extremely simple and gives you ballpark torque values over a wide range of screw sizes and property classes. The ISO standard 898 defines properties for metric fasteners of carbon and alloy steel. And the ISO 898 defines property classes like this 5.6 or 10.9 or 12.9 that define characteristics of the materials. So the formula itself is extremely simple. So let me give it to you now. So the maximum tightening torque is simply going to be the nominal thread diameter that's the diameter of the threads on the outside of them, divided by 11, and then you cube this, and then you multiply it times the first number of the property class, which is the tensile strength index. Tensile strength index. And then you multiply it times the second number in the property class, which is the yield factor. And the resultant values are going to be in Newton meters. So let's go over 6 examples that will demonstrate that this method is surprisingly accurate over a wide range. All right, so let's first look at this. By the way, this torque chart is from Norbar, who's a manufacturer of torque instruments. So let's first take a look at this 2mm screw. This is an M2 screw. And let's say it's a property class 3.6 screw. So we're going to calculate this one. Okay, so the thread diameter is 2 millimeters. Divide by 11, cube it, multiply by the 3, and then multiply by the 6. Let's see what we get for that. Not sure if you can see this. So 2 divided by 11 equals cubed, and then times 3 times 6 equals 0.108. So we will call that 0.11 Newton meters. And if you look here on the chart has a value of 0.12, and we got 0.11 Newton meters. So that matches very closely. So now let's consider a 10mm screw. So this is the M10 screw. Let's do that calculator. So 10 divided by 11, cube it, and then multiply by 3, multiply by 6 equals 13.5. Let's see if that's close. And the value in the table is 16.7. Okay, now let's calculate it for an M42 screw. So M42 is 42 divided by 11 cubit times 3 times 6 equals 1002. And the value in the table is 1304. Okay, now let's take the opposite extreme, a very high-grade bolt, property class 12.9. So for this one, it's going to be 2 divided by 11 cubed times 12 times 9 equals 0.65 Newton meters. You can see this one is extremely close. Okay, let's do the 10 millimeter again, but this time in a property class 12.9. So this is going to be 10 divided by 11 cubed times 12 times 9 equals 81.1 Newton meters. And the actual value from the table is 85.32. So 81.1 Newton meters. And finally, let's do the case of an M42 screw, property class 12.9. And that is going to be 42 divided by 11 cubed times 12 times 9 equals, and that is about 6,012 Newton meters. So 6,012 Newton meters. And the actual value from the table is 6,727. So for these really large screws, this formula tends to underestimate the torque somewhat. But it's rare that you're going to be using screws this large. For a wide range in the middle here, this formula provides a very close, reasonably close approximation of the torque. And this is the maximum tightening torque. You do not want to exceed this torque normally unless you know what you're doing. Okay, that sums it up. Thank you for watching and have a great day. Bye now.